Good morning, team. This is Zach Lasseter with Spatial Vision. This is a demo and tutorial video on the foundation analysis portion of our software. This is our diagnostic software for concrete foundations to let you, as our clients, know whether or not there is significant movement across any pieces of the slab or the foundation, and essentially whether or not that needs to be addressed by work or by further inspection by an engineer or a contractor. The other demo videos for JPEGs and DXF files show you how to get to this portion of the process. So we're going to take off already having our data entered, our 2D map populated, and our 3D map populated. So I'm going to go ahead and click on Foundation Analysis. Yep, start analysis. All right, now we did not break it. What we're going to do is manually calibrate our drawing. So I'm going to click Enter Manually. And now you can see that this north wall is highlighted. This is the boundary that I drew. So what this wants us to do is enter in a known distance of this wall as measured from the outside. And again, this is going to calibrate our drawing. If you don't know this one, you can click Next until you get to the wall that you know. For this dissection, that's going to be this guy. It was 9/11 and 7/8 as measured from the outside. I'm just going to round him to a straight 10.0. The slow version and the fast version, so the difference between the diagnostic calculations for the tilt and deflection measurements, the fast version does 1 pass-through, the slow version does 3 pass-throughs. We can get into the nitty and gritty on the difference between these, but really quickly, the fast version, our diagnostic calculations are going to take a measurement line from foundation edge to foundation edge. We're going to break that into 9 equally spaced points, and then we measure the up and down variation between those points. And we give you a really simple output on the health of the slab, essentially. For the slow version, we do the same thing, but we do a pass-through with 8 points, a pass-through with 9 points on that line, and then a pass-through with 10 points on the line. Mostly our engineers use a slower version, but if you want some individual training or some more information on these, please feel free to reach out to me. For demo purposes, we're going to click the faster version. Great. And now we've automated this process, and again, what we're doing is we're taking and measuring every possible combination of lines that run from foundation edge to foundation edge, are a solid line, so no breaks in them, right? So we can't run through the patio and then across here. Those lines have to be longer than 25 feet, but less than 150 feet. And that's going to show us, or those are the calculation prerequisites that our diagnostics use. So here in a few moments, it's going to give us a total number of lines detected and how many lines it found that met the qualifications that we get to look at. So depending on the footprint of the home, this can take 2 minutes, or if you have a large home with a lot of data points, complex footprint, this might take 5 to 8 minutes. Most of the time it only takes a few minutes though. Great, here we go. So 32,000 lines found, 3,600 within the boundary, 5,100 that crossed without any breaks in them, and out of everything, we got 368 lines that were our measurement calculations that we get to look at. So let's look at our results. Click Show Results. Now we're going to work from the top down. So for analysis summary, you can see here 245 measurement lines passed, 123 failed. So that means they passed either the deflection, which is the up and down portion, or the tilt, which is how far out of sync your corners of a structure essentially are. You can see right now we're looking at line 1 of 368, and we see the worst case scenario first because we want to be able to use these for diagnostic purposes. So the worst measurement in the home, we see that one first, and that's right here. And the way we look at this is the measurement starts on the green dot, ends on the yellow dot, and then these 3 red dots, these are the 3 elevation points that have the worst combined up and down movement. So we're essentially looking for hills and valleys. Oh, it's backwards. Hills and valleys. So we're going to scroll down here, and this is our really simple to understand and look at table of values. Here we have our profile of inputs. This is how long our measurement line is. This is that measurement line broken into 9 equally spaced points, and these are the elevation readings at each one of those points. This is our stratigraphic view. So if you cut that slab or that floor right where this measurement was taken, this is what it would look like from the side. And this is our really simple pass or fail for the deflection and the tilt. And again, deflection is this up and down movement across a straight line, and the tilt references how out of flatness or out of level the corners are to each other. So let's investigate a little bit more and see why this failed. And this is for understanding of the diagnostics, right? So its measurement is starting here, and it's running through this lower area, and then it's starting to ramp back up as it comes across here. So on the 3D map, we're looking at this area essentially here, and it's cutting through this dip and then kind of coming back over here. So at 4 feet, and on the line started at -1.2, right near the wall for elevation. We travel 4 feet, stay at a -1.2. We travel 4 feet, we go down to a -1.9. We travel another 4 feet, and we come up to a -1.1. So in this 8 feet right here, -1, 2, we go down 7/10 of an inch, and then we come back up 8/10 of an inch. So that's 1.5 inches of combined movement over 8 feet. That's why it failed the deflection portion of the calculation. So this portion of the home, that's essentially our green light to either A, offer work to stabilize or level out that portion of the foundation, or B, as inspectors, offer that this space be inspected by a contractor or an engineer because there's significant foundation movement in this portion of the home. When I click next line, I'm going to move to the next worst line, and you can see that line was almost exactly the same. It's just this end spot's a little bit different. So I'm going to look for another line. 3, aha, there we go, line 4. So line 4, we're going to investigate, starts off on the green dot, ends on the yellow dot. These 3 red points are the worst movement. Okay, so I can see what's going on, why it would fail. So at a little over 16 feet, we're at a -0.8. We travel 3 feet, and we go down to a -1.8. So in 3 feet, we've got an inch of movement. And then we come up just a little bit. But these 3 points, kind of this shelf right here, has the most drastic combined up and down movement between any points. And so that's why it fails with a L of 147. Now, when you find lines that you like, you can come up to download foundation analysis report, and you're going to download individual PDFs which have all of the information for each line you are currently looking at. So this is this line, for example. So you can see I get my topo map, my data points, I get my diagnostic line, I get my scale, I get my table of inputs, I get my stratigraphic view, and then I get my really simple pass and fail on the deflection and tilt portions of the calculations. And one of my favorite ways to utilize this when I'm offering this for diagnostics is I like to pick a couple lines that go through issue areas that the homeowner has. So for example, I would definitely choose this line to supply. This is failing the northeast corner. There's definitely some significant movement on. So that would be line 1. I would click through here. All right, so that would probably be line 2. It's failing that same corner from north to east this time. That's pretty close one. That's in the same area though. I want to see if I can't find anything else different. Still failing the northeast. Aha! All right, so now I have a line. This is line 17. That's failing this little area where we've got this depression coming into the south portion of the home. So this will be the last line we look at. And so let's see what we've got here. So we are at about 3 1/3 feet. We're at a negative 0.3. We go down to a negative 0.7, and then we come back up to a negative 0.2. And so this is happening within about 6 feet. So we go down 4/10 of an inch, then we come up 5/10 of an inch. So in 6 feet, we have just under an inch of movement. That's why the deflection portion failed, and that's why this area should be investigated by a contractor, an engineer, or some work can be offered in this area. And that's how we use the foundation analysis tool. The last thing to show you on here, a couple months ago, we built in this button that says View All. And so what View All does is this shows you 20 lines at a time. So we're seeing the worst 20 lines for the whole home, and it's a pretty powerful image, right? You essentially, 18 of these lines are all failing the northeast corner. 2 of the lines are failing this guy right here. And you see we have 120 lines that actually failed the calculation, right? So I can look at 21 through 40. Okay. Still failing the same portions. 41 through 60. Still failing the same portions. 61 through 80. Still failing the same portions. And I can come down here too, and I can look at what each of my values are for each one of the lines that I'm looking at. If I'm like, I want to see what this one is, I can click here. This is line 67. This will pull out line 67 details for me. I can click back to lines, and then I can click download, boom, line 67's report. And then last but not least, this is our formulas and calculations for our deflection. We're really transparent with how we are using the standardized calculations to do our diagnostics. So this is where you can see that. For tilt, this is a definition of tilt, what it means, and how we run the PTI compliant calculations for our diagnostics. Same thing with deflection. This is our information for deflection. Here's your definition. Here's our final deflection results. And then for engineering standards, this is one of my favorite, most important pages for our clients. This tells you what reference standards we're using for our diagnostics, what our L over 360 is, tilt standard, data point spacing, our analysis range, all of that. So this is where you can get a little bit more of the nitty gritty on the actual standards that we're using for our diagnostic calculations. And as always, if you have any questions, please feel free to reach out to me, and I will answer whatever I can and offer you some sort of support and training if you so desire.